Good. So this is the story of one co-housing community. Craig introduced the notion of co-housing communities. This is going back 15 years really, so it was great to hear, that some possibilities for technology that have developed since. But I feel that some of our experience can be helpful really in seeing how to use natural materials for, bulk housing. So how do I do this one? All right. Yeah. So it's easy to see or to understand why it's the passionate owner builders, the owners who want to have an eco house, who hire a small scale building practitioner. There's lots of good reasons why that's where a lot of these technologies are developed, refined, brought back from previous indigenous cultures, etc. So owner builders, single house builders, but they have a real passion about the materials, about using materials that are good for us and good for the planet. They're willing to experiment, and they can respond to opportunities of material supply, of people, etc. They're really quick on their feet with a single house project. They can modify techniques on the job much more easily, and a really important one is, owner builders are prepared to live with the consequences. They're prepared to do the experiments, recognise the mistakes, patch them up, or maintain whatever. So being willing to live with the consequences is a real plus of owner builders. There's another end of the scale, really, another end of the other polarity of getting houses built, and actually many more houses are built by developers. And so just developers who build multi-house developments have a really different set of constraints. So just to outline that other polarity, they're building houses for buyers. They need to have design and materials that appeal, to mainstream buyers. That's, perhaps buyers want what the developers aren't producing, but they need to have some sort of security of people buying their product. Consistency of supply is really important. The materials and the construction systems need to be a reliable cost. They need a range of contractors and subbies skilled in the materials so they get competitive tenders. They want no surprises in construction, and they want minimal callbacks. So that predictability and kind of no disasters is, kind of important for everybody, but in order to get bulk housing, it's perhaps even more important. So those are the continuums, if you like, of two different ways of how our housing is produced. So I'm always much more interested in all the possibilities that happen in between the poles. So there's a whole rainbow of possibilities in between black and white. So let me introduce Earthsong. So as Min said, Earthsong is a co-housing community of 32 houses in West Auckland. It's within the city boundaries. And we have aspects of both of those poles. So it's a 32 home housing development, a reasonably substantial development by anybody's measure, really, for a developer as well. However, Earthsong was developed by a group of individuals, of passionate individuals who wanted to use natural and sustainable materials, who had a real ethic of building as well as possibly could within the bounds of the planet. And because we were a large project, we needed reliable cost and performance. And you know, a lot of those aspects that, you know, that a developer needs and has as important. But because we were a group of individuals, you know, generating our own project, we were willing to make much braver choices than a commercial developer would be, and that's what we did. And it was pretty challenging, but I think that it's kind of useful, I think, to our natural building industry to perhaps identify some of the challenges of using more natural materials on a large-scale project. What are the issues and challenges? So that's why I'm kind of sharing, you know, some of the pain, but also the joy of it as well. So just hoping our experience is helpful. And just to very briefly explain a bit more about Earthsong to give it context. So Earthsong was founded on a very strong vision statement, which basically had three main aspects to it. Number one was environmental sustainability. So we had a vision of building our neighbourhood to the highest practical standards of environmentally sustainable construction that we could. So we had a real ethic of going as far as we possibly could in the design, the layout, the materials, the systems, the services, etc., to put in place, you know, an energy efficient, a low impact environment. And that covered things like location. You know, we bought a site within the city boundary, right next door to our community centre and library and shops and things, walking distance to public transport, a train line, etc. Within the site, we've kept the cars at the edge. It's mainly pedestrian around the houses. The houses are clustered together to give as much open space as possible. They're all passive solar designed, the houses. The materials we used were rammed earth and solid untreated timbers, so kind of half and half. We collect rainwater, we have solar hot water heaters, etc., and overland stormwater. So just every single aspect we went as far as we could to build a sustainable village. The second part of our vision statement, equally as important, was what we called social sustainability. And that's things like recognising that we're not, you know, independent people. Actually, there's a real value in being interdependent with others and cooperating, sharing space, a sense of belonging, a sense of being cared about, etc. Good neighbourliness, basically. So, knowing well and caring about your neighbours in quite a structured way. And that included such things as quite a lot of common facilities. So the biggest one is our common house that's in the centre of our community. It's like a large house that belongs to each of us, is our home, part of our home, but it's part that we share with everybody else, and has a large meeting places and a big kitchen, and basically allows a lot of other things to happen that are very difficult to happen in people's individual houses. It's a neutral shared space. And the other main thing about our social sustainability, or a really important one, is that we make decisions by consensus. So right from the beginning, through the development stage, the planning, the putting it all together, the construction, all of those decisions, etc., and now that it's finished, all of the management, any decision of any note is made by consensus of the full group of members. And we have a range of really good social tools, like our coloured card system, that's part of our decision-making tool. Very, very well thought through agreements, etc., which make that work. And then the third part of our vision statement was around education. So we were always committed to sharing whatever we learned that might be helpful to others. We weren't just building a lovely environment for ourselves. We wanted to share what we knew. So if you go and look at our website, you know, there's a huge amount of information there. Just very briefly to talk about the process, to give it a bit more context. So basically the whole project was developed and driven by a group of people who wanted to live in a more sustainable way and in more cooperation with neighbours. This group formed in 1995. I called a public meeting in 95. Various people joined the group. It slowly grew. We put a lot of effort into our kind of baseline agreements. At the end of 1998, we found the site that we bought. It was a 4-acre organic orchard in Ranui. We did a very intensive design process together, so whoever was in the group at that time had as much input as they wanted in the design process of our neighbourhood, with assistance from our paid professionals, architect, engineer, etc. Through that time and through the construction, I played the role of what we call the development coordinator. So I was the kind of the driver really right through making sure that we as a group thought about what we needed to think about and made our decisions in time, and liaising with all of our outside consultants, builder, project manager, council, etc. So sort of the point person between, it's like a figure 8 between us, the group, and all of our outside people. We started construction in 2000. It was a very long and challenging construction process. We ended up splitting it into 4 different stages and building it over 8 years. And we finished in 2008, all of the houses and the driveway and all of the hard landscaping. So it was a very long and challenging process, and there's several layers to that. So we were a multi-unit development. You know, that's pretty challenging anyway, even probably for a developer, you know, who does it all the time. We had at least 3 more levels of complication, if you like. We were a group of individuals who made decisions by consensus and were driving the project. And there's 2 important words in there. We were all individuals, so a range of diverse individuals with strong views and a shared vision that brought us together as a group. So we operated as a group and worked together. We also wanted to build to the highest practical standard of environmental sustainability, and we also wanted common facilities as well as our individual houses. So it all kind of wraps up to quite a challenging project. Any building project has, you know, time and cost constraints, of course. I think, just when I think about it, ours were particularly stressful, if you like. Basically, Earthsong was funded initially by individual households with their life savings. So, you know, a family probably only has one go at buying or building a house generally, and that takes a substantial portion of your resources. So we were kind of funded by individuals, and we were also funded by a commercial bank for the construction loans, so that brought in a whole other set of very strict conditions that the bank had about how we set up the project legally, and the price that we could, you know, contract for, and then how much money we could pay out on a monthly basis to the contractors, very tightly controlled. So the consequences of a time and cost blowout were enormous. And that's just a sort of graphic really to say that, where's the little pointer? No, can't see it. No, so basically people put in as much as they had to our company. We set up a non-profit company, Co-Housing New Zealand Limited, and that was us, but it was our development entity. People put in different amounts of money, as much as they could afford, to our development company, which made up 20% of the equity that we needed to build the houses. We got a construction loan from a commercial bank for the other 80%. And when the company finished, or the builders finished building all of the houses for the company, then the individual houses were sold to the individual owners at a price that in total covered development costs, so no profit in there for the company. So just thinking about the challenges of that. Some of these challenges, of course, come with any building project, but I've tried to pull out the challenges that the way when we're trying to use natural building techniques and sustainable materials, the ways that made our job more difficult, really, and therefore the point is that gives us, as a construction industry, to what needs to be addressed to make that more achievable by other bulk builders. And I'm going to just go through and give you an example or two of each of those. So, council consents, scale and density, limited choice of contractors, craft persons building production housing, supply issues and variable material. So number one, council consents. Actually, people assume that this was one of the hardest issues. For us, actually it wasn't. It was generally not too hard. Obviously, any project needs good design, good documentation, a good relationship with council and ongoing liaison, which we did, very thoroughly, and that meant that we didn't have huge problems actually with council. So in terms of the unusual layout, the density, the building design, etc., no problems whatsoever actually with council because of the good design and documentation. Because we were using earth building, we have rammed earth walls. Again, that was absolutely not an issue getting consents for our rammed earth walls, and that's because of our excellent earth building standards. I just hats off to those of you who put the effort into those earth building standards. Really, it just eliminated that issue as a concern for council. So, brilliant, really helpful. Thank you. The two issues that we did have, some we had to put in extra work really. There is no treated timber added on whatsoever, not even H1 boric treated framing. No treated timber. We wanted to avoid treated timber. That required a lot of research and documentation and proving that, yes, Hart Lawson Cypress is equivalent to H3.1 for framing, etc. But having, we had to put in that work, but, council eventually said, yep, okay. Another issue was the on-site stormwater, which required a lot of research and documentation, but, again, that eventually got through. So number two, scale and density. I mean, basically, we've got 32 houses on 3 acres, so that's officially medium density housing in the Auckland, scale of things. So 1.2 hectares, 32 houses. And it was designed together as a cohesive neighbourhood. So it wasn't individual design of individual houses. We designed the whole thing together and then progressively built it. So the scale and density issue basically meant that it affected two main things. One was the design and the other was the means of construction. So in design, for instance, because we had terrace houses, joined houses, and two-storey houses to give us the small footprint but sufficient building size. As you can see, most of our kind of basic footprint of the house is rammed earth, a big sort of square of rammed earth, and then in the terrace houses, the upstairs is timber frame, timber clad. As soon as you have a two-storey house and the roof way up there, it's no longer useful for protecting the earth walls from rain, and even in New Zealand you get horizontal rain anyway. But just to say that our engineer and our builders together basically said, okay, so you have to have cement in those walls to give it so there was not the water penetration that you might otherwise get. we were relying on our professionals at that point to advise us about how we needed to design our earth walls. So, that's how it happened for us. We also have some two-storey round earth walls where we have ground floor houses and separate houses, separate apartments above, and therefore a concrete mid-floor. I just love this slide because it kind of shows the bit of Kiwi ingenuity of how do you get the ramming earth from the ground up to the first floor ramming. And these particular contractors, you know, well, of course, you just lift up the wheelbarrow with a digger. Another issue we had with the density of houses and joined-up houses is we wanted to use timber wall cladding. That immediately becomes an issue for fire separation between units. So we ended up putting a little nib wall, you can see, between those two terrace houses on the left there. So, you know, design issues solved it. But we had to go through a whole new thinking process that there wasn't a lot of experience about, because most terrace housing builders use other materials which has a lower flammability index. And the other thing that the density required was basically it wasn't possible to build houses separately. We needed to build them as a group, but we could stage them, and we actually had to stage them because we had to have enough buyers at a particular time to afford to build that bunch of houses. So we ended up building the first 17 houses as stage 1, still a big project, 17 houses together. Then we built the next 7 houses as stage 2, and then the last 8 houses as the last stage. So what that meant was that it wasn't owner-built. We had to hire contractors to build a project of that scale. Which brings me to, when you have unusual materials, there's a very limited range of building contractors who have the skills and the experience in using those materials, and who also have the kind of the size of company and the staff and the managerial skills, etc., managerial systems sufficient to build, you know, a project of that size. Basically, we only identified one contractor who was both skilled in rammed earth, and we felt, you know, had the potential to have that capacity. They'd only ever built single houses in the past, but with project management help, you know, felt they could take on 17 houses together. It does mean with only one contractor identified, it does mean you don't have a competitive tender situation, of course. We actually worked with that contractor from quite early in the design process to design the systems and the details to suit their methods. So they were very involved from early on, and then a negotiated tender process to get to the price to build, which was acceptable to the bank and in relationship to what the valuation that we had that they were going to be worth at the end, etc., etc. Really kind of massaging and tugging a whole lot of different threads and constraints till they met in the middle. Quite a challenging project. So we were very dependent on basically on that one contractor, and you know, that's just one reality, I guess, of building a multi-house project, or at the time it was, year 2000. Number 4, you'd think that with building 17 houses that there would be cost savings in bulk buying and systems and all of that, and I'm sure there are in the systems that you've developed, Craig. In our case, it turned out actually we were building crafted houses. We were building a lot of them, but actually they were crafted houses. They were rammed earth, a lot of labour content, a lot of skill required, and also pretty much all of the joints were visible. So as soon as you've got visible joints of timber into rammed earth or timber joining, etc., it needs to be skilled carpentry, because you can't cover up the missings with gunk or paint. It's all visible. So we did end up with crafted houses, and that's lovely. We absolutely love them. It just means that they didn't, we didn't get the cost savings that you might otherwise get. Supply issues was quite a big one, particularly in stage one. So with natural building materials, they're not generally, well, a lot of them aren't available off the shelf. You have to seek out your sources. 7 minutes, Rob. Okay. So, as I say, we built in rammed earth and a lot of solid untreated timber. So there's no particle board or NDFs. There's a tiny bit of plywood. All there is solid timber for the upstairs wall structures, the roof structure, the wall cladding, the floors, etc. We used macrocarpa, Lawson cypress, poplar, and cedar in stage 2. Not readily available in bulk at that time. So what we did in stage 1, actually working with the contractors and their systems, they said, let's buy the trees. So actually that's what we did. We, the company, forwarded money to the contractors to buy some trees of the appropriate type. The contractors organised to get them milled, to get them, logged, milled, transported, seasoned. All of that, it turned out a total nightmare. Basically, when you've got 17 houses worth of timber of various types, various dimensions, all needed at different times, it was a logistical nightmare, and it was a very wet winter. That winter, it was a total nightmare getting it all seasoned in time to be used. So, just to say, good idea, but it was a huge logistical nightmare that set us back quite considerably in our program and therefore in our costings. Because as soon as you borrow money from the bank, it's thousands of dollars a week in interest running all the time. And the last one I'll cover is variable materials. So most natural building materials, by nature, they're less processed, they're less homogenised, they're kind of straight, used in their natural, close to their natural form, and therefore they're more variable. That's lovely, when you see a natural house, that's part of the beauty of using natural materials. In a big scale construction, it can start to be a problem. So the example I'm going to tell you about is our ramming earth. Our stage 1 rammed earth walls, beautiful, strong, lovely, they were really good. Our stage 2 rammed earth walls, beautiful, went really well. The last stage of the last 8 houses that we built, the walls just weren't coming out right. Something wasn't right with the walls. They were quite soft and crumbly on the surface. They were dropping bits off. Little cracks were appearing all over it. Obviously, we had a problem. So a lot of testing was done of those downstairs rammed earth walls. A lot of water penetration testing, and actually, it turned out they failed quite badly in a lot of areas with the water penetration. So the water was travelling much further into that earth wall than it should be. So, major headache, months actually of trying to work out what was going on. Put a stop on the construction because we needed to work it out before finishing the earth walls. What it turned out after testing of the actual ramming earth was that the clay content had dropped to quite a low level in that ramming earth. So the clay was dug out of an earth quarry. Basically, in the time between getting a sample, ramming sample cores, getting it tested and finding that that's fine, in the time between that and actually digging the earth for the construction, I guess it had moved to sufficiently different part of the clay bank that the composition was different. So once we'd found that out, we could do something about it. We actually used lots of testing, working out how to do it. We actually ended up using a half and half mix, so adding in half the random earth coming from a different quarry, which had a much higher clay content. So it's all possible to to tweak this and fix it, but in a big project that had enormous implications, for our contractors, for us as our non-profit company, for all of our individual house owners, sort of mortgages running, trying to get into their new house, etc. Huge implications. So we did make a fix, and I really want to say that in this case the contractors worked with us incredibly closely. It was a very collaborative effort working out what was going on and coming up with a fix. So yeah, I'm really sorry that Alan's not here at this conference, but shoulder to shoulder on that one. And we did have to do a bit of a fix for the lower, softer walls, putting hoods around to make sure that they all had quite a bit of weather protection. And they're performing pretty well, actually, but it was something that needed addressing. So, just to finish, really, what we've ended up with is we have beautiful houses. We absolutely love living in them. They're solid, they're warm in winter, cool in summer. The sound insulation between the terraced houses, fantastic. Really good fire insulation as well between houses, etc. Really good performance. We absolutely love the houses, and people that come through say, wow, these are beautiful houses. So it was quite a challenging process, and I think we learned a lot, and we've ended up with a lovely place to live. And it just feels really important that we as an industry really share the things that we've learned about our projects, and particularly the painful bits, because that's how we can learn to do it, to make it more viable. And I love it when people build their own homes. They're really special places, but personally I think that will only ever be quite a small proportion of houses. We need a lot more houses, and there's a lot of people who have other things that they want to do with their lives, and they still want to live in a low impact, non-toxic, beautiful house. So we need to learn how to translate those things that we're learning into more production housing and do it better. And Craig's shown us one of those ways, and really appreciate that. And there's a lot of other ways perhaps as well that we can do it. And so just to say, that's why I'm part of YIPFI. I just really think it's very important that we share all of our stories and what we've learned and make them available to us as as anyone really interested in building, so that we can, so it makes it more accessible, more possible to use those materials in a wider range of projects. So